Hello, and very warm welcome to the MyAware presentation on Lambert-Eaton myasthenic syndrome. My name is Laura, and I'm one of our national support coordinators, and I'm joined by Charlotte, who's our research and partnership manager. Charlotte's going to provide us today with an overview of Lambert-Eaton myasthenic syndrome, which we are hoping should be a useful tool for you if you have LEMS. But you can also share it with friends and families or even healthcare providers who would like to learn more about it. Lambert-Eaton myasthenic syndrome, or LEMS, simply put, disrupts the communication between the nerves and the muscles. It's named after two neurologists, Dr. Edward Lambert and Dr. Lee Eaton, who identified this syndrome. The 30th of March is Lambert-Eaton myasthenic syndrome Awareness Day in the USA, and we are partnering with the Lambert-Eaton LEMS Family Association to raise awareness and bring this day to the UK for the first time this year. As this is a recording, if you would like to stop the video at any time and come back to it, you can do so. Or if you have any questions or comments, please do contact us on the email support@myaware.org. And without further ado, I'll pass over to you, Charlotte.
Thanks very much for that, Laura. That was great. And I will just share my slides for everybody. No point in asking if anyone can see that because this is a recording, but that's fine. So welcome everybody. Good morning, good afternoon, good evening, any time that you're watching this in particular. As Laura said, I'm Charlotte and I'm the Research and Partnerships Manager at myAware. And today I'm going to give just a brief overview of Lambert-Eaton myasthenic syndrome, how it works, how it's diagnosed, what current research is ongoing into this disease, and basically just a whistle-stop tour of how it may affect you or your loved ones. So without further ado, we'll go into the first slide. Now, anybody who might have been on any of our presentations before know that I like to try and keep these things as educational as possible. So we're going to start with a little bit of taking overly complex words that are often used in biology and research and break them down into what they actually mean, because I think that will help understand what is quite a complex disease a little bit easier for folks, no matter what sort of background they have. So 5 key words that I'd like people to remember or to be able to understand what they mean by the end of this presentation, or even just one, every day's a school day. These would be starting with synapse. So for those who don't know, synapse is just another word for the moment when your nerve and muscle cells communicate, essentially. It's when a message is shared between your nerve telling your muscle to do something such as contract. Another phrase that I'd like to pay attention to is the neuromuscular junction. So we've talked about synapse. The neuromuscular junction is the site of that sort of communication. It's what's referred to as the space between the nerve and the muscle cells. And further on into the presentation, we'll get a picture of what this actually looks like. Another word I'd like to pay attention to is the neurotransmitter. Now, this is a fancy term for a chemical messenger that is basically acts a little bit like a postie and shares messages between nerves and muscle cells into around the neuromuscular junction, and essentially is the nerve. Sort of kind of like, an email, or as I said, a postman saying from nerve to muscle, please contract, please do these things, and that's how they work. Another phrase is autoimmune. This one might be a bit more familiar to folk, but when we refer to a disease as being autoimmune, what that means is that it is where the body basically attacks its own parts. It looks at a part of itself, which is normally kind of natural and naturally occurring, and thinks that it's maybe something foreign, like when we have a cold, our body, our immune system will respond to attack that cold, say that it's not meant to be there and get rid of it. Well, unfortunately, this mistake happens in autoimmune diseases where the body responds in a similar way. And the final one, which is a bit fancier and a little bit harder for me to say sometimes, but it's paraneoplastic, which is particularly prevalent when we talk about a disease such as LEMS. And this is when the immune system has a reaction to a cancerous tumor, or another word for that is a neoplasm. And we'll talk a little bit more why that has a role to play in LEMS a bit further on. So now that we've got our sort of morning starter for 10, we'll go into a bit more of a detailed breakdown of how LEMS works. So as I said, we've got a little picture here of the neuromuscular junction. And that is this space here we see between these channels. We've got this lovely light lilac axon or nerve cell, kind of shaped a little bit like the bottom of a leek, if you think about it. And then we've got the surface of the muscle, which is more of a purple. I try to stick close to the myaware colors as best I can. And we've got these little channels as well. And then we've also got these little red bubbles, and these are neurotransmitters, which we've also covered previously in the last slide. So this is an example of someone who did not have LEMS and how the communication between their nerve and muscle cells would occur. Basically what happens is we've got a calcium coming in. This is a little channel here, and when that calcium binds with its channel on the nerve, it allows the release of these neurotransmitters. These ones in particular are called acetylcholine. And when calcium binds, it allows the acetylcholine to bind to the muscle cell. It passes through from nerve to muscle, and that message of contraction is allowed to happen. If we look at someone with LEMS, what happens instead is we have this autoimmune response, which is when an antibody, this little green fella here, binds to the calcium channel that we previously saw binding calcium, and it basically blocks up this channel, which means then the calcium has nowhere to go, it flies away. The little bubble that would normally release acetylcholine remains closed, and we don't get that release or that message sharing with or shared between the nerve and the muscle cell, which then symptomatically is the sort of muscle weakness we would see in LEMS. Now, we know that LEMS is a myasthenic syndrome. We also know that there's a lot that we do know about myasthenia gravis, which is the more common type of myasthenia in the UK. And they do have their own similarities. They both have symptoms of fatigable weakness. They are both autoimmune diseases, where LEMS is more acting on these calcium channels. We know that MG is more involved in sort of channels that are involved in the muscle cell. So things like the acetylcholine receptor or LRP4 or MuSK. But we also know that both these diseases respond to immunosuppressive therapy, largely because they're autoimmune diseases. Now, where these diseases differ, as we said, is primarily on the site where we see that autoimmune response. So we have these voltage-gated calcium channels, which we saw there previously on our little neuromuscular junction. That is the site of the blockage. In MG, as we talked about, different sites on the muscle, ACHR, MuSK, LRP4. We also see with LEMS that standard symptoms onset on the proximal muscles, and in MG, it's more ocular, meaning in the eyes. We also know in LEMS that weakness improves with exercise, where it's the opposite in MG. And we also know that there's often a strong association with cancer, which relates back to that word we talked about with neoplasm and neoplastic, whereas the association with cancer in MG is a lot less direct. Now, I've spoken about the strong association between LEMS and lung cancer, and this is primarily related to small cell lung carcinoma. Among small cell lung carcinoma patients, or SCLC, approximately 1 to 3% of these patients will develop LEMS. However, if we flip it and we look at LEMS patients as a population, 50 to 60% of these patients are called paraneoplastic cases, i.e. they've originated from a cancer. And this is because the voltage-gated calcium channels that we talked about previously are present on a lot of lung cancer cells. And so we again see that autoimmune response that affects the neuromuscular junction in the lung cancer cells. We also know that this is quite an aggressive form of cancer, that it can be metastatic, meaning that it can spread to other parts of the body beyond the lung. We know that the symptoms are related to chest pain, shortness of breath, and these are all associated with a poor prognosis. And the SCLC has a strong association with LEMS and Cushing's syndrome. So how is LEMS itself diagnosed? So diagnosis can involve a range of tests, including physical examinations that involve assessment of muscle strength and deep tendon reflexes. So if anybody has ever had that little test where they hit your knee with a hammer, which is also known as the knee jerk test, or clinicians can also use testing such as electrophysiological studies or nerve conduction studies which involved delivering an electrical pulse to a nerve and measuring the response to the muscle, which as we can see in this little graph here. So in LEMS, there is generally a low CMAP, which is a phrase known as a low response at rest. But with repeated stimulation at high frequencies or after brief exercise, there is a greater than 100% increase in the muscle response. This is likely due to the increased release of acetylcholine with sustained activity. Now, LEMS patients commonly use 3,4-DAP, which is a medicine that works well with LEMS. And how that works is that 3,4-DAP functions to improve the release of acetylcholine. As we can see here, this drawing here is used again, the same little red ball that we used previously. So again, we're seeing this neuromuscular junction. We're seeing the axon or nerve cell here and the muscle. This is a little curvy, wavy thing here in the space in between where that communication takes place. So it helps enhance muscle strength, and it does this by blocking up the channel that controls the exit and entry of potassium, which is this red one, this blue one here. So these three different neuromuscular junctions we're looking at. This is for someone who doesn't have LEMS. This is for someone who does. And this is for a LEMS patient who is being treated with 3,4-DAP, as we can see with this big red triangle. So you can see it's working on the potassium channel, which is blocking this up. And if we imagine the potassium and calcium channels, they kind of act like doors into the nerve cell. Usually one can be open at one time and one remains closed. So with 3,4-DAP keeping the potassium channel closed, it means that the calcium door stays open for longer and allows a greater influx of calcium into the nerve and encourages the release of acetylcholine. It's kind of like increasing your chances of success by having more calcium available by keeping this potassium blocked up. And that's how it works in a very sort of simplified explanation. Now, what do we know about current research into LEMS? There's not enough of it, as we know with a lot of the myasthenias. New therapeutics are not yet quite being trialed in LEMS, but as soon as we do hear about any that are being, we'll obviously keep myAware members informed via either our website or on Zooms. We do know that there has been a study which has been published last year looking at a therapy called CAR-T. And basically what CAR-T does is we know sort of the immune system uses cells known as B cells and T cells. And T cells have a role in sort of coordinating what B cells do. And B cells help coordinate our immune response, which we know plays a big role in LEMS and MG. And what this study did was they had two patients, two women. This took place in Germany. And these women in particular had concomitant MG and LEMS, meaning they had both myasthenia gravis and Lambert-Eaton myasthenic syndrome. And how CAR-T cell therapy works is that they take the cells out of the patient. So this is again going to be a very simplified summary on something that is quite complex, but they'll take T cells out of the patients, they'll take them into the lab, and they will genetically modify those cells and then infuse them back into the patient. So they'll basically affect the function of that cell to allow it to do something that helps improve the immune response or modulate the immune response that we see in MG and LEMS. So with both of these patients, they experienced clinical remission post-treatment with a follow-up of up to 7 months. And if I can go to the next slide, it'll help detail patient A and B and all of the different treatments that they tried leading up to the infusion of the CAR-T cell therapy. And as you can see, this is a number of years of trying multiple different therapies, experiencing multiple crises, and struggling to find something that worked for them, particularly with their very unique cases of having MG and LEMS. That's a word too difficult for me to pronounce at this time of the morning. And basically, if you go to the last slide here, we can see their sort of quantified results of how their myasthenia improved after therapy. So we're looking first at their quantified myasthenia gravis scores, their QMG. And as you can see here, as we go this little graph at the bottom, we have days after the therapy and how their scores improved. We know with a lot of these scoring systems, the myasthenia, the lower your score, the better. It's a bit like golf. And we can see that these scores were improving post-therapy. We also can see that their walking distance was greatly improving as they went post-therapy up to measuring, if you look 3 months there for patient 1, and the difference between how far they could walk comfortably. They also looked at their vital capacity, which is, related to their breathing and how comfortably they were able to breathe and take air into the lungs. And this also kind of, as you can see, jumped all about the place a bit. What was definitely improving overall in patient 1 and 2. Patient 1's been treated a lot longer than patient 2, which is why the lines don't quite end at the same place. And then finally, we have the last scoring system for myasthenia symptom severity, which is the MG-ADL score. And again, the lower your score, the better. These are looking at functions such as things that mean like standing up from a chair, or being able to speak and swallow and things like these that myasthenia affects those muscles for. And as you can see, post-therapy, that these patients have had a really good result in improving their myasthenia scores, their myasthenia symptoms. And this paper was published last year, and I will get this shared alongside the video for anybody that wants to have a read. And if anybody has any questions on how it worked. I will also say, if you do go to look at the paper, there are a few videos of the patients so you can properly see the improvement in their walking post this therapy. I will say that CAR T therapies are very, they're not necessarily new, but they're very complex and they take a long time to develop. They're also very expensive because, like a lot of genetically modified treatments, they're kind of a one and done type approach to therapy, which means you would have one treatment and then be measured for how well you respond to that. So we're a wee ways off this sort of being a thing that is widely available for folk. We know that the NHS is slowly introducing CAR T therapies for diseases such as cancer, but nevertheless, it's encouraging to see that these type of therapies can work for diseases such as myasthenia. And I think that's all for me today. Thank you very much for listening. And if there are any questions at all, please feel free to get in touch with us, and I'm happy to expand.
Brilliant. Thank you very much, Charlotte, for that really helpful overview. If you would like any further information, or you'd like to join our myAware LEMS community, we have a free lifetime membership, which includes our dedicated LEMS online Facebook support group and regular online meetings to support you. Thank you very much for watching, and have a great day.